Hello, I'm Mr. Precella, and today in algebra we're going to be solving absolute value equations. We've been solving a lot of equations lately, solving linear, solving quadratic. The last time we looked at solving rational and radical equations. Here we're going to have equations that have absolute values in them. So the natural question is, what the heck are absolute values? Let me review that for y'all. Okay? These vertical bars here are read absolute value, and generally speaking, the absolute value of x denotes the distance between 0 and the number x on the number line. The use of that word distance. Distance can never be negative. If someone asks you, what's the distance between here and Houston, it wouldn't make sense for you to say negative 220 miles. Okay? So absolute value never equals a negative number. Suppose we had this, the absolute value of, how about 5? Absolute value of 5. Well, if we think about the number line and we were counting how many spaces are there between 0 and 5 on the number line, well, it would be 5. The absolute value of 5 is 5. Now let's suppose we have a negative number inside the absolute value bars. The absolute value of negative 7 would be what? Just a 7. It's okay to have a negative number inside the absolute value bars, but you should not have a negative number over here on the right. Okay? In general, the absolute value, and it doesn't matter if the number inside here is positive or negative. Doesn't matter. The answer, which word am I going to write over here? Positive or negative? Positive. Okay. So, I think I finally got it fixed, right? It's not going in and out of focus, is it? Or is it doing it and I'm not noticing it? Okay? Now, we're actually going to solve some equations here. So let's solve this one. An equation has an an equal sign in it. Suppose we had this. The absolute value of x equals 3. Whenever you're trying to solve an equation, the answer is always going to be x equals some number. Well, here, let's logic it through based on what we know. What number could x be in order to have absolute value equal to 3? 3 or negative 3. Okay? X equals positive 3 or negative 3. If we look at the homework. We'll make it a little bigger and do this. Is that a little easier to see or not really? The absolute value of x equals 18. Okay? There's some math problems that we'll do, and lately it's been every one of them, that in order to do it, you got to scribble, scribble, scribble to get an answer. Is this one of those that's going to take a lot of scribble, 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 or you just read it and put in the answer? Yeah, you don't really need to write anything down for this. The absolute value of x equals 18. The solution would be positive 18 or negative 18. The answers talk about separate with a comma, and you can write it like that, 18 comma negative 18. But a lot of times those instructions, especially with the quadratic formula, those were written before they introduced this plus minus key. So you really don't need a comma here. You can just say plus minus. What number am I going to type here? 18.
You wouldn't have to write, would it be wrong if x equals?
I'm thinking it wants not to write the x equals. That's a good question. Let's see what would happen. I think it's going to mess up the formatting, but let me see. No. Okay, I don't know what's wrong. But they just want you to type in the 18 and the negative 18. So the plus minus 18. Notice it still says check answer. So that means I haven't used up all my guesses yet. Okay. Now you'll notice this little option right here. The solution set is the empty set. I wonder why they're mentioning that. That's the same thing as saying there's no solution. Let's look at problem number 2. I think I'll write it down. The absolute value of x equals, what is that, a negative 9? Absolute value of x equals negative 9. Where's that cursor? Well, let me lift this up a little. What do you think the common wrong answer is? Do you also do this? Plus minus 9. Why is that wrong? What's wrong about this problem? The negative on the right. It doesn't matter what number is inside the absolute value bars. If it's positive or negative, your answer is still going to be positive. This is a type of equation where there's no solution, or, depending on what the option is, it might say empty set. Right? And sometimes instead of writing out empty set, you might see on a problem as the semester goes, it's a circle with a slash like that, which means empty set. But I think here, what did it do? It just had the words written out, didn't it? Let me see. Problem number 2. Am I going to click on A and put in plus minus 9? Or, hey, I wonder, what would happen if they do that, if I did that? Oh, look, it didn't even give me the option for the plus minus. I can always type it in, like this, negative 9. Okay, so I thought maybe it was smart enough to say something like, hey, watch out. There's a negative number on the right, but it isn't. So on this one, you don't do that. You just click empty set. I put that negative 9 in just for illustration purposes. So you see what happens. It's wrong. So if there's a negative number on the right, it had no solution. Now, problem number 3, we're getting them a little bit more involved. There's not a negative number on the right, is there? It's a positive 21. Let me write this one down. The absolute value of x minus 7 equals 21. Maybe I better lift this up a little more. Okay. Well, there's a positive number on the right, so this one has a solution, and we know how to solve it if it had just been an x in the absolute value bars. Okay? So this one has one extra step on this one that problem number 1 didn't have. Let's think our way through this. There's some stuff in this algebra class this semester you'll be like, okay, I'm just going to accept that. I don't understand why, but I'm going to accept it and go on. Well, here I think you can understand why on this one. Let's cover up that x minus 7. Looking just at the red absolute value bars, what are the only two numbers that can possibly be in there? Forget the x minus 7. Just what are the only two numbers that can be in those red absolute value bars to have absolute value equal 21? 21 or negative 21. So take what's inside here and set it equal to positive 21 and set it equal to negative 21. You're going to get two answers here. Oh, someone asked, what's the purpose of the color? Sometimes that means something. Other times it's just to break up the monotony of this, of seeing just all black, right? So now we want to isolate the x. This is a linear equation. That's not an equal sign there in front of the 7. It's a minus. I thought it looked too dim, and I made it worse because now it looks like an equal sign. So how would I isolate the x? What would I need to do? Okay, add 7 to both sides. My little move the 7 over and change the signs. So what number would x be? At 28. Since 28 is all you're going to type in, I'll just circle that. Okay. Now that one you can check real easily in your head. If you plug 28 in for x, 28 minus 7 is 21. Yeah, the absolute value of 21 is 21. Let's come over here and solve this one. I would be adding 7 to both sides. So we have x equals, say it again, negative 14 is right. And if you could check it if you wanted. Negative 14 minus 7 would give you a negative 21. Aren't those the two numbers that have to be inside the absolute value bars? Either a positive 21 or a negative 21. This is a very logical way to go about solving this stuff. So we'll punch in these two answers and what was it? 28 and negative 14. Okay, it's just getting a little bit more involved.
And then it's wrong in the opposite there is 21, so I probably wouldn't have done the negative 14. Then, on the last question.
Oh, let me look back. So what would you have done?
I would have just put 28 because it's 21 with the answer.
Oh, but inside here, you could have 21 or negative 21. Just like right here on this one. The answer wasn't just 3. It's 3 or negative 3. Okay? When solving an absolute value equation, what you're going to be doing is going equal positive, equal negative. That's the little phrase I use. Equal positive, equal negative. And that's what we're going to have to do on this one here. Let's see. Let me write this one down. Let's see, it's number 4. Mm-hmm. 2x minus 5 equals 6. So here is number 4. Solve absolute value of 2x minus 5 equals 6. We're going to use the same logic we used on the previous problem. Cover up that 2x minus 5. What are the only two numbers that can be inside those red absolute value bars? 6 or negative 6. So you're going to make what's inside here equal 6 or negative 6. Oh, I'm thinking we're going to wind up with a fraction on this one. Or maybe a couple of fractions. Let's see, how would I go about this one? I would add 5, move the 5 over. So we have 2x equals 11. And then divide by 2. So 11 over 2 is one answer. What about the other one? Move that negative 5 over. And what this arrow means is this. If this is what you're accustomed to doing, writing the plus 5, that's fine. Then you'd have a 2x equals negative 1. Divide both sides by 2. So a negative 1 over 2. So 11 over 2 and a negative 1 over 2. If you put an 11 over 2 in for x, that's going to give you a 6 inside there. If you put a negative 1 over 2 in for x, that'll give you a negative 6 inside the absolute value bars. The only thing that can be inside there are plus or minus 6 if it's going to equal 6. Okay? So that's the logic here. Why are we going equal positive, equal negative? Any questions on that? Patch it in. 11 over 2. I'll hit a right arrow and then the comma. Negative 1 over, I'm just hitting the slash rather than using the fraction key there. If you want to use the fraction key, that's fine. 11 over 2, comma, negative 1 over 2. Okay. Before I write down problem number 5, I want to write something on my paper here. Oops. I'm even going to put a red star out beside it. Let me lift it up. It's an important rule. Whenever you see absolute value bars, always, I'm going to say it, but I won't write it. I'm going to say it 3 times. Always, always, always isolate the absolute value bars first. The absolute value bars should always be by themselves on one side. Like here on number 4, notice the absolute value bars were by themselves. There was nothing else over there. And on the other problems we've done, like number 3, absolute value bars were by themselves. If you're wondering, what the heck does he mean by themselves? Well, compare it to this one. Number 5. This is problem number 5. The absolute value of 2x minus 4 equals 14. There's only one correct first step here. And you've got to do it before you do anything else. Move that 4. The absolute value bars should be by themselves. Y'all see what I mean by themselves? This minus 4 shouldn't be there with them. So I'm going to add 4 to both sides. Or in other words, move the 4 across the equal sign. So here's the equation I'm solving. Absolute value of 2x. Oh, duh. Thanks. There. Okay, so move the 4. And I'm solving the equation. Absolute value of 2x equals, is that going to be a 14 plus 4, 18. So now, let's think. What's that logic for solving an absolute value equation? Yeah, positive and negative. Equal positive, equal negative. Either you have a positive 18 inside these absolute value bars or you have a negative 18. Okay? So I'm solving the equations. 2x equals 18 and 2x equals negative 18. We lift it up a little. So divide by 2 on both of them. What are we getting as our answers here? A 9 and a negative 9. You can type those in as 2 separate answers. Or you can, if the plus minus key is showing, you can use the plus minus key. But I'm always getting emails from students saying it's not showing the little buttons. You've got to click inside the box before you start seeing the little, right there, plus minus. Plus minus, what was it? Plus minus 9. Oh, wow. Okay. Now there's a fraction, but we can handle it. Let me write this one down. This is problem number 6. Absolute value of 2x minus 3 over 9 equals 7. Okay, so here's number 6. Well, apart from the fact that there's that fraction, it's still basically the same type of problem. If I covered up what's inside the absolute value bars, the only numbers that can be inside there are 7 and negative 7. So you just have a little bit messier equation to solve, but not real messy. So take what's inside there, go equals 7 and equals negative 7. And I'm writing it as 7 over 1. If you just want to multiply both sides by 9, I always think cross multiply for some reason. 2x minus 3 equals 63. So it's really, even though there's a fraction and it might look intimidating at first, it's really, one extra step. You get rid of that fraction. So how would I solve it from there? Let's see. Would I move the 3 over and then divide by 2? So let's see. I move the 3. So we have 2x. Is that going to be a 66? 6, and then divide by 2. I seem uncertain. Did I mess up? 33. I was in here this morning at 6:30, and the cleaning man came in, and he asked me, "Is it okay if I only wash the whiteboards once a week?" Oh, it's okay with me. I thought I never use it anymore, but then it dawned on me. Now it's dawning on me. Wait a minute. What if it looks bad for the projector? Well, if that's the case, I always have some erasers. I can clean it myself. Okay? Let's see. So 33 is one answer. What's the other answer going to be? 2x minus 3 equals negative 63. Did I hear negative 30? Because I think I agree with that. You add the 3 to get a negative 60. And divide by 2. Negative 30? Is that what y'all got? So we have a negative 30 and a 33. Negative 30 and 33. Doesn't matter which one you list first. And 33. Okay. Oh, wow. Are we about to do the last one? It's the last one, so it has to be the hardest one, right? Oh, sure. I'm sorry. I want to see. Is there anything strange about the instructions on it? What was it?
The worked out.
Oh, you want to see the worked out? Oh, okay, that's fine. Okay. So you take what's inside there, set it equal to positive 7 and equal to negative 7. I'll refer to as equal positive, equal negative. If you're sitting there wondering, now wait, we're getting all this stuff. How do I know when to do what? If there's absolute values in it, that's when you go equal positive, equal negative. Have we had anything with absolute values this semester up to today? No. That student years ago that told me his teacher was an idiot because he made him look at the problems and study the instructions and stuff. That's actually a good idea. You should be able to say, how does this problem differ from what we were doing the last time, and so forth. Okay? Any questions there? Before we do the last one, which has to be the hardest one. Oh, wait. There. Let me write it down. Absolute value of m plus 1 plus 4 equals 16. Well, don't get carried away and start equals 16 equals negative 16. I remember a rule, red star rule. Always isolate the absolute value bars first. Okay? What am I saying we have to do first on this problem number 7? Yeah, I have to move that 4 over. There's really no other correct first step. You move the 4 over by, what is that, subtracting 4? So here's the actual equation we're going to be solving. Absolute value of m plus 1 equals, is that going to be a 12? Now, are we ready to go equal positive, equal negative? Yeah. So we'll say m plus 1 equals positive 12. And m plus 1 equals negative 12. Let's see. Oh. Subtract 1. Are we getting an 11 as the first answer? And then over here, what are we getting? It's not a negative 11, it's a negative what? Negative 13? Oh, let me lift it up. So positive 11 and negative 13. Positive 11 and negative 13. Oh, wait. Come over here and punch it in. 11, comma, negative 13. Notice you can check this one. It's easy to check. 11 plus 1 is 12. The absolute value of 12 is 12. Plus 4 is a 16. Doing the same thing with the negative 13. If I put a negative 13 in place of the m, negative 13 plus 1 would be negative 12. But once I take the absolute value of negative 12, I just have 12 plus 4 is a 16. So I'm confident those answers are right without even, before even checking on it. Okay. Any questions there? Let's see, if there's been a negative over here.
If it was a negative 16 across the equal sign, that would be empty set.
Yes. In fact, let me make up an example.
Start only the actual isolating absolute value.
It's after you isolate. I'm glad you asked this question. Well, you can't see it yet, but I'll reveal my example I'm making up in a moment. Let's see. Suppose it had been a x plus 2 plus 8. Let's look at this example I just made up. Absolute value of x plus 2 plus 8 equals 3. At first glance, there's not a negative on the right-hand side. But once you isolate the absolute value bars, okay, you've got to isolate those absolute value bars before you decide empty set. Okay? That should always be the first thing you do. Right here, when I move this 8 over, I'd have absolute value of x plus 2. Now, what number do I have on the right? Negative 5. We can stop right there and say no solution or empty set. And I know there are some times on Pearson where it won't say empty set. It'll say no solution. Okay? But if there's the number on the right-hand side is a negative, then that's when you have the empty set. But you got to make sure before you do anything that those absolute value bars are isolated. Okay? So once I isolate them, then I notice, now, just maybe I'm beating a dead horse. Oh, that's a disgusting thought. But I'm making another example I'm going to show y'all. This one looks sort of like the one I just did. Nope, wait. Nope. Oh. I didn't like that example. Let me make up another one. There's a particular type of one that I have in mind here. If I can get it done. I wanted it to look like the one I'd just done. So here's another example. I'll show it in a moment. Absolute value of x plus 2. There. Okay. So here's the empty set example. This one you wind up with empty set. But what about this one right here? Okay. What would I do first? So I'd have to move that 8 over. And so at first glance, if you see that negative on the right, you might think empty set. But wait. First, you've got to isolate those absolute value bars. And once you isolate them, I don't think you still have a... It's just a 5. So, do I write empty set or am I not finished? You're not finished. This is one where you have to go equal positive, equal negative. So, x plus 2 equals positive 5. X plus 2 equals negative 5. So my first answer, is that a 3? So here, negative 7. I agree with that. Okay, so 3 and negative 7. Oh, wait. Oh. Saw it there. Always isolate the absolute value bars first. Now,